Okay, thank you very much again, Rosa. Our third speaker is from the industry, Mr. Paul Pandrea. He is a civil engineering graduate from the Technical University of Munich with specialization in structural design and geotechnics. Since 1998, Paul has been working in various capacities for Keller, a geotechnical specialist firm with branches in over 40 countries. Currently, he is the technical director of the firm's European division. Like our other speakers, Mr. Pandrea is also very active in various working groups, both in Germany and in Europe. He is, for instance, the chairman of the European Committee for Standardization Technical Group on Ground Improvement and the convener of working group for the revision of the norms relating to ground treatment by deep vibration. Mr. Pandrea is also a board member of the so-called friends and supporters of the Institute of Geotechnics of Darmstadt. So he actually does not have much choice but to be here and support us. So proud.
Thank you very much. Well, I'm presenting the industry view on that and also recapping a little bit on the panelist discussion which we had previously. So we as an industry, what is our role? Our role is basically to build this resilient infrastructure. So that means we put piles or other elements into the ground where this infrastructure is resting on. And well, you have probably seen a number of definitions for resilience, so I can skip this probably. The strange thing is, if you look into all those formal documents which we use for design, for example, into standard codes, and you are searching there for the term resilience, it doesn't really appear. So maybe you'll find it in a foreword, but it's not even a defined term. It's just used as a word. There are other terms, and here you have a short view on what is coming, and the terms that are used are terms like reliability, and this reliability is probably the main term. So the main concept which is used in our current and future generations of codes, design codes, and this covers safety, serviceability, as we have established in our previous discussion. That's a bit like performance, durability, and also there is another term, and that is robustness. Well, you know, currently, if you look into the codes, you have to make a design. First of all, it's ULS, and as a second term, SLS. Well, historically, of course, ULS has been the dominant one, and SLS was nice to have. That has changed. So already in the current generation of Eurocodes, ULS and SLS, I would say, are equally important. And as we have seen in our discussion, SLS most of the time is controlling our designs. So we install piles, and basically they would have a bearing capacity, but sometimes the deformation is limited, so I'm not allowed to use this bearing capacity, the design bearing capacity, fully. And there are, of course, definitions for robustness and durability to be found in those codes. And as we have seen, most of the time, still this boils down to certain factors of safety, and those factors are then used to determine quantities. So basically, what we as a contractor want to know when we go to a site is how much do we have to do for this project. So that means how many piles, what diameter, what length, how much reinforcement. And the, let's say, conventional wisdom is that if we stick to all those current regulations, we do nothing wrong, and the result is assumed to be robust, durable, so in other words, resilient. And this goes basically for most of our products, whether it's piles for a bridge abutment, other examples of critical infrastructure. Here you see, for example, the preparation of the ground for a wind turbine. This is an example from Poland where we are using deep soil mixing. And again, it's basically a question of ULS and SLS. How much of those elements do I put into the ground? How much cement do I need to mix into those columns so that I achieve a certain material strength, which is sufficient? So in all those designs, the sequence is basically, I need to make sure that at least the internal force in my element is not exceeded, because once that would be exceeded, I would have something like a system change, because then the column crumbles and I have a different system then. I want to avoid this. So this is also something that somehow is covered by the way we do design today. Of course, sorry, was a bit quick. If I go to roads, different types of ground improvement. In this case, you see here stone columns, which we install. Also a means of ground improvement. And this ground improvement basically, or most of the time, is used as a pure SLS, so performance improvement measure. It also increases stability. So the factor of safety against base failure will also increase, but most of the time, this is also governed by performance criteria or serviceability. Another critical infrastructure is tunnels. And of course, in tunnels, you have to make a distinction because the tunnel itself is a permanent structure. But of course, to build the tunnel, you have a lot of temporary works to do. So you have excavation support, which is only needed as long as the full tunnel is not finished. Once the tunnel is finished, it either completely or at least large parts of it become redundant, obsolete. And the question is, of course, can I make a distinction between temporary works and permanent works? In Germany, we are used to that. So currently in our version of the Eurocodes, we have, if you look into the tables for safety factors, we have 3 columns. We have one which is permanent, one we have transient or temporary structures, and one is accidental. If you look into the future Eurocode, at least in the original version as Sen is looking at it and trying to publish that, this line, this intermediate line, temporary, transient, is disappearing. So the factors for transient and permanent, at least in that form, will be identical. And at the moment, we have a lot of ongoing discussion if we are allowed to reintroduce in our national version of the table this middle column with a transient or temporary verification case, as it's called now. And that has a certain implication to which I will come a little bit later. And this implication has to do a little bit with those sustainability goals. I mean, all those 17 goals, we have already touched them in the previous presentation. They are very high flying. So we as an industry, we deal only with a certain part of those goals. Of course, in our policies, we deal with gender equality, and good health and well-being. So we have health and safety programs in our business. Of course, as an industry, we try to be innovative, and we try to be fair. And here you see climate action, and climate action for us means basically decarbonizing our business. We as Keller, we have analyzed our carbon footprint a little bit, and those are figures from 2020. So we said our scope 1 and scope 2, that's about 176,000 tons of carbon equivalent. That's what we have found. So summing up all our diesel consumption, electricity consumption, transportation, and so on. But scope 1 and scope 2, that's probably far less than 20% of our whole footprint, because the majority of our footprint is buried in materials. So basically, the quantities we install in the ground control the carbon footprint of what we are doing. And what we are using on site. So here I have gone into a database and dug up some figures. So basically 1 ton of diesel is an equivalent to 2.6 tons of carbon. And of course, still today, most of our equipment on site is diesel powered. So there are hardly any piling rigs or driving rigs or any other rigs that are not diesel powered. To decarbonize, we have to find different ways to power our equipment. The other very heavy carbon footprint increases are steel. Steel, more than 1 ton per ton of steel today, as long as we do not go into recycled steel or steel where we are using something with hydrogen in that. There is a lot of use of geotextiles today in the industry. Of course, the quantities compared to the whole volume are not very big, but the material itself, plastic, which is made from crude oil, has quite a considerable carbon footprint. And then it goes down to average cement and concrete. And of course, you see also here we have different concrete grades. So that means, do I really need a very high strength class, or can I build it with a lower strength class? That alone makes a certain distinction. And then you see, if I use natural material like gravel, for example, we are using that in our stone columns, that has a very, very tiny footprint. And of course, if I'm able to come up with something in my project where I'm able to use wood and I'm able to protect this wood, then I'm installing a kind of a carbon sink into my project. So those are things which we need to consider if we want to decarbonize our business and also to decarbonize the way how we are building critical infrastructure. Well, that sounds a bit theoretical, but it is also very practical. We as a company, so we are stock listed, and of course we could simply wait for the governments to make some laws that would force us to decarbonize. But there is a different, let's say, actor which forces us to decarbonize, and those are investors. And those investors have basically brought us to this plan here. So we have to decarbonize, and here you see scope 1, scope 2, scopes 3. So we have promised basically that by 2030 our scope 3 emissions will be 0. So basically the electricity we will use. That's probably fairly easy because we just swap to renewable energies. Scope 1, that's a bit more tricky. So that's all the diesel, and that is up to 2040. So until then, and that is less than 20 years from now, we will have to find ways to power our equipment completely without producing any carbons. And in 2050, so that means 28 years from now, we have to get rid of all the footprint that is in our materials. And that is the biggest challenge. First of all, because it's the largest part of the footprint. And second, of course, because it's also the most difficult to do, because how to replace cement, how to replace concrete, how to replace steel. That's a question where we don't have a final answer at the moment. And so the question or the balance we have to find basically with all those things, with the quantities and sustainability, is of course a new balance between resilience expressed in robustness and durability, boiling down essentially to safety factors, and as a consequence of that, to quantities. So how much are we putting into the ground, and sustainability. So do we spend a bit more on materials, having more resilience, but accepting a larger carbon footprint today, because today we have to build with today's technology for the next 50 years? Or do we accept a bit, presumably less resilience, but save on carbon footprint today? That's a question we need to find a new balance. And this is something we cannot answer alone. This is something that needs to be answered by the whole community. So that starts down from politics over the owners of critical infrastructure. So what do they want? What do they order? And down to us, to the builder of the critical infrastructure, how we are approaching this, how we are doing this in reality. Thank you.